I how this diagram looks like. So this is how a dendrogram looks like, where it has one node and then another and then it multiple subtype. Moving on, what are the advantages over of hierarchical clustering over k-means clustering? Why are they better? So, firstly, dendrogram representation, as I mentioned earlier. Secondly, that is, it creates a dendrogram that is again a tree-like structure which visually represents the nested relationship between data points, and then there is no need to predefine cluster. That is, unlike k means, hierarchical clustering does not require specifying the number of clusters in advance. Instead, the dendrogram allows user to choose the number of clusters dynamically by selecting a threshold. Third is better insights to a cluster. That is, it provides detailed insights of how data points are grouped and how it is useful for understanding. Next on, we have flexible cluster shape. That is, key means use spherical clusters which may not work well, but hierarchical clusters are more flexible and captures non-spherical clusters effectively. Now it also handles small data sets better. That is, it uses more interpretable and provides better visualization than k-means. Moving on to our next question, that is, what are the advantages and disadvantages of decision tree for classifying tasks? How to ensemble the random forest and boosting to improve this performance. So, advantages of trees. Firstly, they are simple and interpretable. That is, decision trees are intuitive and easy to understand. They mimic human decision making by recursively splitting data into smaller subsets based on features threshold. The resulting tree like structure makes it simple to trace logic behind the model's prediction, which is valuable trait for interpretability. Now, second point is no data normalization required. That is, unlike some machine learning algorithms such as KNN or SVM, decision trees do not require feature scaling or normalization. This is because they split data into based on their thresholds rather than calculating the logics or distance between the points. Unlike that's what k-mean clustering does. And then next is handles both categorical and numerical data. That is, decision trees are versatile in handling both types of data uh, that are categorical, and then they can process numerical values and categorical values and making them suitable for a wide variety of tasks. Next point is future importance. That is, decision trees provide valuable insights into the importance of in each feature. By examining feature splits, we can determine which feature contributes the most, making to make the predictions. This helps in the feature selection for the future model. Next on, we have non-linear relationship. That is, unlike linear model, decision trees can capture non-linear relationship between features. By splitting the features into specific regions, they can model the complex patterns and interactions between the features effectively. Next on, we have inference. So once the tree is trained, making the prediction is computationally efficient, since each decision at a node involves a simple comparison and the prediction time is fast even for large data sets. Now, what are the disadvantages of it? So, firstly, overfitting. That is, that decision trees are prone to overfitting, especially if they are allowed to grow, or if they are allowed to grow. And in such cases, what happens is that they capture not only the underlying patterns but also the noise fluctuations in the training data that leads